Hello there, I'm Preparer here and I'm with Vultr here, Vultr. In this tech talk, we'll discuss deploying Vultr cloud resources using Crossplane, which is an open source Kubernetes add-on that doubles as an infrastructure as code tool that lets you deploy several types of resources right into your Vultr account. To begin with, Crossplane is the infrastructure management tool that runs on top of your Kubernetes cluster environment to actually extend all cluster functionalities with support for external resource deployments as regular Kubernetes objects. This lets you query external resources as regular cluster objects. For example, you are able to use commands such as kubectl create, kubectl get, kubectl delete to query these external resources right within your cluster without causing any conflict with any existing Kubernetes cluster objects. In addition, Crossplane automates the deployment of cloud infrastructure resources from YAML files. This lets you have a single management file with all your cloud resources defined into it. And when resources are deployed with Crossplane, it goes ahead and synchronizes and manages the existence of these cloud resources using API keys. In short, Crossplane is that one tool that will let you create, manage, and monitor the existence of your cloud resources right within your Kubernetes cluster environment without actually using multiple tools to perform the same task. How it does this, it uses the Vultr Crossplane provider configuration to actually authenticate and verify the existence of your cloud resources. The Vultr Crossplane provider is a configuration that resides within your cluster, enables and validates additional Crossplane resource types such as instances, databases, among others, right within your cluster. How it does this, the Vultr Crossplane provider manages Crossplane communications to your Vultr account using a valid Vultr API key. For each Crossplane request that comes right into the cluster, the Vultr Crossplane provider configuration validates and uses your Vultr API key to actually deploy or monitor a resource on your Vultr account. And as its main functionality, the Vultr Crossplane provider extends Crossplane with Vultr-specific resource specifications and values you can use within your cluster. This means you are able to use key tags such as plan, OS, location, among others that match the Vultr API specifications. But then, what do you benefit by using Crossplane over other tools? Crossplane enables the automatic deployment of Vultr cloud resources right within a centralized environment, which is your Kubernetes cluster. Instead of having to deal with multiple machines, a single team can actually manage resources right within a single Kubernetes cluster. In addition, Crossplane enables the automatic synchronization and monitoring of the existing cloud resources right within your cluster. This means if a resource is deleted, Crossplane will strive and try to recreate this instance with its specifications as described in your cluster unless turned off. And for simplified management, Crossplane offers unified control and management of cloud resources with a single control plane, which is the actual Crossplane resource that runs within your cluster. This lets you use tools such as kubectl, the Crossplane CLI, and the Crossplane Web UI that you can integrate right within your cluster to actually manage these resources. And so, to deploy resources, you simply have to come up with a YAML file configuration, specify your resource type and specifications you would like to deploy to your Vultr account, and then use a command such as kubectl create or kubectl apply to actually deploy this resource in your Kubernetes cluster. Crossplane will take over the process of synchronizing with the Vultr provider configuration, which in turn queries your Vultr API key and authenticates if it's valid and deploy these resources right to your Vultr account. So, let me take you through a demo where we shall actually deploy a Vultr cloud instance, a Vultr managed database for MySQL, and Vultr Object Storage right within a Vultr Kubernetes Engine cluster. And so, without any further ado, let's jump right into it. To get started with our demo, I have already deployed a Vultr Linux server to use as the management workstation. And now, let's go ahead and deploy a Vultr Kubernetes Engine cluster to use with Crossplane. First off, access the Vultr customer portal, click Products, right within Products, find and click Kubernetes, click Add Cluster to spin up a new VKE cluster. Enter a descriptive name of your choice in the cluster name field, for example, Crossplane cluster, keep the latest Kubernetes version selected. Optionally, enable high availability and the Vultr firewall to boost up your cluster availability and security respectively. So let's scroll down to the cluster location section and choose your desired Vultr region to deploy the VKE cluster to. For example, let me select Paris, France. Scroll to the cluster capacity and enter descriptive label for your cluster nodes. For example, Crossplane nodes. Choose the total number of primary nodes to associate with the cluster. For example, leave 3 selected, which is the best recommended minimum for production grade clusters. Let's select a node pool type and plan. For example, since this is simply a management cluster, let me keep optimized cloud compute selected with the best plan of 2 virtual CPUs and 4 GB of memory to use with the cluster. Click deploy now to create the new VKE cluster. So let's give this VKE cluster deployment process some time to complete, probably around 5 minutes. Now, when the status changes to running, let's click the VKE cluster to access its control panel. And now click download configuration to download the YAML kubeconfig file to use when connecting to this cluster. Click to open the downloaded file. Select all and copy the file contents to your clipboard for use with connection using kubectl. Now to connect to this cluster, let's navigate to the Vultr Linux server SSH session that I'm using as my workstation to activate this configuration file. But first off, verify that Snap Package Manager is installed by querying the version. As you can see, the output, Snap is available. So what Snap does, it hosts multiple packages that may not be available with default package managers such as apt, DNF, or pacman, depending on your operating system. Now that we have Snap installed, let's go ahead and install kubectl using Snap, and make sure you add the classic flag in order to correctly install kubectl on this workstation. So give it a minute to download all packages and have this package installed on the workstation. So now that it's successful, let's install the Helm package manager using Snap again with a classic flag in order to install the correct package for this system. What the Helm package manager will do, it will install several packages to our Kubernetes cluster and be able to use them as needed. So now that Helm and kubectl are installed on this workstation, let's switch to the user home directory in order to set up our VKE cluster configuration file. Let's use a text editor like Nano to create a file, say vke.yaml or any other naming scheme you would prefer. So go ahead and paste the VKE kubeconfig configuration. So this is how it should basically look like. And now save and close this file. Now let's export the kubeconfig environment variable with this configuration file as the value. So export kubeconfig, make sure it's in uppercasing, since Linux tends to focus on the casing of each and every element. So I'll use the home symbol in order to reflect to my user home directory at vke.yaml. So we've set up the VKE cluster configuration in just 2 steps. Pasting the file contents to a new file, and then exporting the kubeconfig environment variable for use with kubectl. To test if this configuration is correct, let's view the cluster nodes. And as you can see in the output, we have 3 nodes that are ready. So this means that we have successfully connected to the VKE cluster and ready to use Crossplane. Now it's time to use Crossplane and install all relevant packages on this cluster. So first off, add the Crossplane repository to your home sources. Helm repo, add Crossplane stable, and then add the Helm repository link. So now that we've added the Crossplane repository to our sources, let's go ahead and update the Helm repositories. So by default, Helm uses your kubectl configuration to connect to the Kubernetes cluster. Let's go ahead and install Crossplane to the VKE cluster using Helm in a new Crossplane -system namespace, which is the default. So if you like to use any other namespace, you can simply declare here and make sure that each of your configurations actually uses this namespace. So let's give it a few minutes to actually install to our VKE cluster. This should take about 10 seconds, as you can see in my output. If you focus on this home command output, verify that this installation is successful by checking the status right here, which shows deployed. So, and you can see the namespace is Crossplane namespace. So these are 2 details you should look out for, since the namespace is critical for any other configuration that you may apply from this step forward. Let's view all resources in this new Crossplane Crossplane system namespace. Now, as you can see in my output, we have a couple of resources, including RBAC, that are going to be used with Crossplane. So these are custom resource definitions that Crossplane uses all through the cluster in order to actually manage the infrastructure deployment process. Now that we have Crossplane actually installed in this VKE cluster, so let's go ahead and grant Crossplane access to a Vultr account. But first off, let's view the cluster nodes in a wide mode to expose each of the nodes' external IP addresses. So as you can see in my nodes, you should focus on this very first node because it's elected as the main node in your cluster, and all external requests will be or may be processed using this IP address. So to enable cross-plane communications with your Vultr account, you need to actually enable the Vultr API key if it's not enabled on your account. Then allow the VKE cluster's main node IP address, select it and copy it to your clipboard since you will be using it for this purpose. Once you've copied it, let's go to the web browser, click account this time around, find and select API from the other section items, and now click enable API if it's your first time using the Vultr API key. When you click enable API, it will generate a new personal access token. And as you may see in my output, we have the prompt API access enabled, and now scroll down to the access control section, and now let's paste in the VKE main node IP address in the respective field. And now in the slash subnet here, let's use /30 since most Vultr IP addresses tend to use a subnet. So click add, and as you can see, our API access list is updated and we have the new address allowed to access this API key. As a basic security practice, it's not recommended to allow all IPv4 addresses since it may turn out to be a security threat on your account. Now that the VKE node IP is allowed, let's scroll up a little bit and click the copy symbol right here to copy the Vultr API key to your clipboard. And let's switch back to the SSH session. Let's open a new file, say vultr key.txt, paste in the Vultr API key, and now save and close this file. So we're simply doing this to safely secure this key and be able to use it on this workstation all through without having to look over and over again. So far, we have created a VKE cluster. We have connected to a Vultr Linux server to use as a workstation and then connected to the actual VKE cluster. In addition, we have installed Crossplane, and now we've set up the Vultr API key to use with Crossplane and allow communications from the VKE cluster itself. This means we are ready to use the Vultr provider extension with Crossplane and be able to deploy resources right within the VKE cluster. So let's proceed forward. Now that we are ready to install the Vultr provider extension, first let's create a new project directory to store the Crossplane YAML files. For example, give this new directory name something like Crossplane-files, simply for organization purposes. So let's switch to this directory, plane files. Now let's create a new file, provided.yaml or anything that we like to name it, but provided.yaml will distinguish it amongst other files that you may have in this directory. And in order to populate some data into this file, let's switch back to the web browser, and this time around, let's navigate to the Vultr Crossplane provider repository. So right within this repo, click examples to open this directory, and now see this file install.yaml. Click to open this file, select and copy all the file contents listed here, and now let's switch back to the SSH session and paste these contents right here. So what this configuration simply does, it enables the Vultr provider extension for use with Crossplane in your cluster. So you can give this provider a new name, but for easy identification, we can maintain provider-Vultr since it's quite generic enough. So save and close this file. Now let's apply this resource using kubectl to the VKE cluster in order to install the Vultr provider extension. Give it a second to actually apply this configuration. So now that it's successful, let's create another file this time around to store the actual Vultr API key. Let's give the file a name something like Vultr API-secret.yaml. So this will simply define a new secret resource. And now to populate some data into this file, let's switch back to the web browser, navigate a step back to examples, and click the provider config directory this time around. Open secret.yaml.temp. Now that it's open, select and copy all contents from this file. Switch back to the SSH session and paste the contents of this file. Let's save and close this file. And now, before we actually apply this configuration to the cluster, it's incomplete, so we need to populate it with our Vultr API key. So let's use the cat utility to actually view all contents in the Vultr key.txt file we created in our user home directory. So now that we have the key, simply select it and copy to your clipboard. And now open the secret resource file again. This time around, let's scroll down to the credentials section and replace the pre-filled put your API key here flag with our Vultr API key. So let's save and close this file. Let's apply this secret resource file to the cluster. Now it's time to create the actual Vultr provider configuration. Let's open up a new file. We can give it a name. Very text something like Vultr-provider config.yaml. Now, to populate some data into this file, let's switch back to the web browser. Let's switch a step back to the provider config. Open the provider config.yaml file. Select and copy all contents from this file. And once you have them, switch back to our SSH session and paste these configurations to the file. So just to scan through the configuration, the file references the Vultr provider extension as the API version. The cluster resource type is listed with a kind directive and its provider config. This means this configuration is strictly to be used with Crossplane. And now if you scroll down to the metadata, we have this default flag. Now verify the credentials part. This file will simply reference the secret resource, so it will be able to use the Vultr cred resource when deploying resources to your account. Let's save and close this file. And now let's apply the Vultr provider configuration to the cluster using kubectl. So give it a second to actually install into your cluster. And now, as you can see, it's successful. And at this very moment, we have installed the Vultr provider extension, added your Vultr API key to the cluster, and applied the actual Vultr provider configuration to use when deploying resources using Crossplane in this cluster. With these 3 core Vultr provider Crossplane resources available in the cluster, it's about time we actually deployed some resources to our Vultr account. So let's get right into that. First off, let's organize this project directly a little bit. Create a new directory. Let's give it a name, something like Vultr provider configs. Let's move all existing .yaml files to this directory. Now that we have actually cleaned up our directory and are able to actually know where each file will be stored at, so let's actually go ahead and create some sample resources. For example, let's create a sample Vultr Cloud Compute instance that we can use to host basic applications such as a WordPress site or any other application that you may wish to use. So let's open up a new file. Let's give it a name such as cloud-compute.yaml. And now that it's here, to populate some data into this file, let's switch back to the web browser window. So let's move to the root of this repository in order to actually view all files. But this time around, let's find the click examples generated to use some default Crossplane values. So within example generated, click the Vultr directory, which is the last on the list right here, to access some additional YAML files. Since we are deploying a Vultr Cloud Compute instance, open this instance.yaml file, select and copy all contents from this file, and let's switch back to the SSH session and paste these contents to the file. Just to take you through these specifications, the API version once again points to the Vultr Crossplane extension. So Kubernetes will identify this as a Crossplane object, and also if you verify the kind specification, it's of the type instance. So this means it's a cloud compute instance. So if you run a command such as kubectl get instance, it will actually run and it will return all resources that are associated with the instance name tag. Within the metadata section, the annotation section points to the Vultr Crossplane instance extension, while the labels section has some interchangeable values we can actually interswitch depending on your needs. So let's give these values a new name. For example, if you start with changing my instance to production server, let's do the same to the next label. The name label will identify this resource. So when you run your command, the resource name will be returned by Crossplane for easy identification. If we scroll down to the spec section, which is the most important and includes all information about the target cloud compute instance specifications. If you focus on the OS ID, the default 1743 value translates to a Vultr operating system. Let's change this to something favorable. Let's say 387 for Ubuntu 20.04. So if you like to see like a whole list of supported operating systems and their responsive IDs, please feel free to visit the Vultr API and copy the call request in order to actually see some of the supported OS IDs you can apply in your instance. So if we focus on the plan, this dictates the main cloud compute instance backend specifications. By default, you can see we have a VC2, 1C, 1GB. What this means, it simply means the type is a Vultr cloud compute, which is VC2, and then 1C translates to 1 virtual CPU, and 1GB translates to 1 GB of memory or something you can call RAM. For example, let's change this to something more desirable. Let's give it VC2, 2C to represent 2 virtual CPUs, and 4GB to represent 4 GB of memory. So this is fair enough for most sites, and it will handle a good lot of traffic depending on your application needs. If you focus on the region field, it's where we actually get to set up the Vultr location to deploy this Vultr Cloud Compute instance to. The default C value translates to the Seattle, United States region, but let's send this to another location that is quite more to our needs. For instance, let's use EWR, which translates to the New Jersey Vultr location. So these name codes and many more, you can use the Vultr API page to actually run a call request view or supported Vultr location. So now let's save and close this file. This configuration is ready to deploy, and I think we are ready to see the first cloud compute instance we can actually deploy with Crossplane. So let's apply this resource to the cluster using kubectl apply. And now once this is deployed and ready, let's go ahead and query its status. And as you can see, the synced tab has a true value, but we have a false value in the ready column. This means this instance is currently deploying on our Vultr account, and we can actually access the Vultr account to verify if indeed there is something that is going on right there. So if we go to the products page, I'll refresh the page a little bit. So as you can see, we have a new cloud compute instance in our Vultr account, and it's linked to the New Jersey location, and its status is installing. So this means this will remain the status until it's successfully deployed and switches to running. That's when Crossplane will detect the results. However, in cases where your instance is actually missing, you'll have to use a command such as kubectl describe instance with the resource name to actually get to see what the potential cause of this error could be. In most cases, you may have applied a wrong OSID code, a wrong Vultr location, so verify the potential error that is making your processes fail. Now that we have our server in the running status, let's actually run the kubectl get instance command again. And now as you can see, the ready column has turned to true, synced is true, and this means the deployment process is complete and the instance is actually created. So just like that, we have deployed a Vultr Cloud Compute instance with Crossplane. So to experiment with Crossplane a little more, let's create one more resource type. This time around, let's create a Vultr managed database for MySQL. So within our SSH terminal, let's create a new file, say vultr database.yaml. Yet again, to populate some data into this file, let's switch to our web browser session to view the Vultr repository. And this time around, take a step back to the examples generated directory. Click database. Open the database.yaml file, select all, and copy these contents to your clipboard once again. Now let's switch back to the SSH session and paste the contents to our managed database file. So just to scan through these YAML configurations once again, the API version points to the Vultr Crossplane extension, and the cluster resource is of the kind database, so this means it's a managed database. Within the metadata, the annotations are correctly point to the Vultr managed database extension within the Vultr provider configuration. And now we have some modifiable values. In the label section, let's change the resource identification name from my database to something like example-database. So in the name tag, let's use the same to give the Crossplane resource this name for it to use within the cluster. And now let's scroll down to the spec section. The database engine directive currently pre-filled with a PG value. PG translates to PostgreSQL, but let's change this to our target database engine, which is MySQL. So in the database engine version, first, let's go to the Vultr account, databases, verify the latest MySQL version. So here it's version 8.0. So let's switch back to our terminal and replace 15 with 8.0. And now, in the label field, this is the descriptive name that will appear in your Vultr account. Unlike the Vultr Cloud Compute instance we created, we did not apply a label field. If you do apply a label field, your instance will actually have a distinct name. For example, let's give this a name, production database, to identify this instance in our Vultr account. So within the plan directive down here, this is where the actual managed database backend plan gets a change. So you can view an entire list of supported Vultr plans by running the matching call request using your Vultr API key to actually see what plans you can actually apply. But in this case, let's keep the default starter plan, which uses a one virtual CPU as represented by 55 GB of storage and 2 GB of DDR4 RAM. If you focus on the region value, let's replace EWR with the Amsterdam just to create a variation of resources for you. So let's save and close this file. Let's apply the resource to the VKE cluster in order to deploy this managed database with Crossplane. And so just like that, we have deployed this resource. So let's query using kubectl get to verify if Crossplane is actually successful and is actually syncing values. So you can see the synced tab is true, but the ready column is false. This means that Vultr managed database is actually being deployed. So let's switch to our Vultr account. Click products, click databases, and now you can see that you have the database actually in the rebuilding status. So let's give the deployment status some time. So now after something like 5 minutes, let's query the Crossplane resource again to verify if there is a change. And so as you can see, the ready column is now true and the synced column is as well true. So this means our deployment is actually successful now. Let's actually verify that indeed the database is running and it's in a healthy state. So let's switch back to the Vultr account. And as you can see, the database status is running. If we click the database to actually access its control panel, you can see that the database is ready to use and it has all the 4 values that we need. If you'd like to explore more additional configurations such as database replicas, users, and new databases, please feel free to visit the Vultr repository and modify the included sample files to match your needs. So far, we have deployed a couple of instances. We have deployed a Vultr Cloud Compute instance and a Vultr Managed Database for MySQL. So these are quite good instances to try out since we have deployed them to multiple locations. So right now, let's try something even more amazing, Vultr Object Storage. So right within our project directory right here, let's set up a new file. Let's give it a name, something like VOBJ, standing for Vultr Object Storage. Just to pimp this file a little more and give it some context, let's go back to the project repository. So switch back to the Vultr directory right under examples generated. Click to open the object storage.yaml file. Select all content from this file and copy them to the clipboard. Paste these contents to the file. And as you can see, just like other files, the API version points to the Vultr Crossplane extension. The kind is of the object storage resource type. So the cluster will be able to identify this since Crossplane uses these custom resource definitions as native Kubernetes objects. So in the labels, this is where we actually have information we can change. So let's change the labels a little bit. Let's replace TF with something like my object storage. Now navigate down to name and we can use the same name. For example, my object storage. Now, if you scroll down to the specification section, you can see that we have something called cluster ID. So cluster ID is the actual Vultr location ID. For example, this value 2 or the number 2 translates to the Vultr New Jersey location. Not all Vultr locations have Vultr Object Storage enabled. So we can simply choose any other number. Let's select something like 4, which translates to the Singapore Vultr location. And in the label field, this is to identify our instance right within our Vultr account. So let's replace a Vultr Object Storage with something like example Object Storage. Save and close this file. And let's apply the resource to the cluster. You can see the command is successful. Now let's query the status of the Crossplane resource. kubectl get object storage. And as you can see, the synced value is true, but the ready column is false. So this means our Vultr Object Storage is still in the deployment phase. Let's verify that by going into the Vultr customer portal, click products, expand cloud storage, and click object storage. You can see that our object storage is actually active now and it's deployed to the Singapore location. Vultr Object Storage is quite faster to deploy, so it takes about a minute. So let's navigate back to our SSH session. If you run the command again, we shall see that the ready column is now true and the synced value is true. So just like all other resources, if you delete the Vultr Object Storage resource in your account without actually using Crossplane, Crossplane will persistently redeploy this resource in order to have it running. So just to recap, we have deployed a Vultr Cloud Compute instance, a Vultr Managed Database for MySQL using Crossplane, and Vultr Object Storage or using Crossplane in your VKE cluster. To manage these resources, you can either use the Vultr customer portal or the Vultr CLI to view the instance details, among other options, right within your terminal session. And so, you can also run multiple Vultr API requests to view details you can actually include in your Crossplane YAML files to successfully deploy resources in your Vultr account. All in all, as we have experimented in this demo, Crossplane is that infrastructure as management tool that will run within your Kubernetes cluster to deploy resources in your Vultr account. It may be similar to tools such as Terraform and TerraGrant, but the major difference is that you define resources right within YAML files instead of configuration files that may be written in other languages. For more information about Crossplane, please feel free to visit the official documentation. And if you'd like to explore more Vultr provider configuration samples, please feel free to visit the official repository. And so, I hope you enjoyed this tech talk. And if you did, I'd like to thank you for watching.